Hey guys, I realized I didn't do maximum subarray, which is essentially the most basic of greedy problems. So we're gonna do that now. So, yeah, let me just explain the problem. Is given an integer array nums, find the subarray with the largest sum and return its sum. So basically, the intuition for this problem is that we want to maximize the current sum that we have, essentially, right? This is also a algorithm. Um, Sorry, the push list problem is actually a famous algorithm. It's known as Kadane's algorithm or Kadane's algorithm. You can look it up. It's very popular for working with maximum subarray sum problems. But the essential logic of the problem is, say we have this array right here, right? So basically we just iterate through the array. Also, this algorithm is O of n time, and it's pretty efficient. The I guess the naive way would probably be to iterate through the entire array and generate all the possible subarray sums, which would probably be O of n squared, and then finding or having a max, and then setting up a max, and then I guess just iterating through each and every possible combination of numbers. But there is a more optimal way, which is using Kadane's algorithm. So what we're going to be basically doing is for each sum that we have, so here it's negative 2 and 1, we calculate the sum, so negative 1 here, and we basically compare the current number we're iterating through and the sum that we would get if we included the previous element into the sum. So here it's negative 1, and 1 is greater than negative 1, so we actually shouldn't include the 2 here. So we shouldn't include the 2. We're going to try and generate another sum starting at 1. So here is 1, and we're going to now take negative 3 into the mix. So negative 3 plus 1 is negative 2, and negative 2 is greater than negative 3. So we're going to retain this sum right here. And let's check for 4, right? So currently our sum is negative 2. Let's check for 4. 4 plus negative 2 is 2, right? And 2 is less than 4, so we should just start over from 4. And we keep on repeating the same process until we generate the largest sum. And then we can do that by just tracking the, you can track that with basically like best sum as the variable. Best sum, and then we just track this, whatever it is, right? And essentially, what we're trying to do here is we just maximize, or not maximize, but we just try and get the greatest sum that we can. If that sum is smaller than the number we're iterating it forwards to, we just start over, right? There's no point in trying to basically maintain a sum of, here it's 2, right? There's no point in maintaining 2 if we can just start over from 4 and see where it takes us, right? Because 4 is already greater than 2, so there's no point in trying to maintain this. We just start here, right? And then we keep on iterating through the array. So here 4 4 minus 1 is 3, but 3 is still greater than 1, so we choose to retain 1 and keep on pushing forward. So 3 plus 2 is 5, and 5 here is also greater than 2, so we also retain 2, and so on and so forth until we find the maximum subarray, which is 6, by the way, because yeah, this is where the algorithm sort of finds the max array. So, what we're gonna do is we're gonna track the best sum, which initially is 0, or let's just say it's nums 0, and also current sum should also be at nums 0, right? And for num and nums, So we iterate through all the nums, except for the first number, actually. Right? For num and nums, we just want to check, is the current number, so let's just rename this to current number. So is the current number, if we add it to current sum, is that greater than the current number by itself, right? So if current sum plus current num is greater than the current num by itself, then we simply append current num, we simply add current num into current sum, and we maintain that sum. If it's not, then we start the current sum at the current number that we're iterating to, because we're restarting the array, right? So let's say we're here on this index right here, right? When we're here on this index, we check if -2 plus 4 is 2, and that's smaller, so we restart the sum at 4. And so we create this new partition here at 4, right? So that's this part. If not, that's this part, right? And then each time we find a new current sum, we simply check if we can overwrite best sum. Because, we may find that the current sum is greater, and the current sum, the greatest subarray may not be at the end. So we want to basically keep on checking if the current sum is the best sum, essentially. And then we just return the best sum. And that should pass the test cases. Submit that. And yeah, that's basically the max subarray. Hopefully the explanation wasn't too bad. But yeah, the intuition is just keep on checking whether or not we should restart. And I think the main point of greedy is just find at which point do we restart or expand our partition, basically. Restart or expand. And if we find out those two things, we're basically golden. We just need to figure out, when do we restart, when do we expand? That's it. And I think that works for essentially all greedy problems. Is think of it as sort of partitioning the array and trying to compare what we have to the best thing we can get, essentially. And yeah, that's maximum subarray. Thanks.